This episode is brought to you by you, our listeners and Patreon supporters. You keep the algorithm fed and the analytics running. If you want to support the show further, go to patreon.com/afks. That's patreon.com/afks. And become a member for as low as €2 a month. You get early access to all the content without interruptions and a spot in our wall of supporters. And now back to our scheduled programming. Welcome back, everyone, to another episode of Away from the Keyboards, the show that uses Excel as a distributed database. Today we have a great episode lined up for you. My guest is Ergest Xheblati. He is the author of the book Minimum Viable SQL, a collection of best practices and data patterns that will help you move your SQL from good to great. We will deep dive on how his experience as a software engineer shaped the way he writes SQL nowadays. So, if you are a data engineer, data analyst, business analyst, or just a data curious person, this show is for you. So sit back, relax, and join us for this great conversation. And if you get any value out of this episode, drop in a like and subscribe to the show. That helps us a lot. Share it with a friend and comment about any subjects that you would like to hear next. Any interactions will help us reach out ever more people. So without any more babbling, Ergest, welcome to the show.
Thank you for having me.
One thing that I would like to know, like you have been an author and an architect, but how did it all started? What is your origin story?
I've got an interesting career journey, and it started out. So I've always been interested in kind of electronics. Later on, I got into computers, into programming. So when I went to college, I studied computer science, and I really like the kind of the algorithms classes. That was my favorite. So again, I got a computer science degree, but when I graduated and I did an internship at a startup, and they asked me to code something in Python. Mind you, this was before Python was famous, and I had only studied Java up to that point and a little bit of C, and I struggled a lot. So for whatever reason, I decided, okay, programming isn't for me. But then I didn't know what to do. Like, what do? You have a degree in programming, in computer science, and then you don't really know what to do with your career. So I went back to school to get a master's in business, so an MBA, which is kind of what you do when you don't know what to do. Luckily, there I met a friend who kind of said, "Hey, we need someone with your background who can help us with some like project management type of stuff." So I started working part time as a business analyst. That was the title, business analyst. I hadn't even like I always wanted. I knew that I wanted to be somewhere between business and technology. I never wanted to go full in any one of them, right? And so this role, the business analyst, happened to be perfect combination of just the business and the technology side. It wasn't what you would consider today a business analyst, so it wasn't like a data analyst. It was more like a product manager type of role, right? So I would speak to the business, figure out what they needed, and then take that requirement, create tickets, have the engineers work on it, make sure that it was working, test it, and then release it back to the business. So that was how I got started. But while I was doing this, I also learned SQL, and I really liked it because it seemed to be something in between programming and something that wasn't just quite coding. It was just something in between. I really liked working with data, and I was building SQL queries for reports that the company needed. So I was building these dashboards very early on. There weren't any BI tools that we were using, so I was sort of just coding them in ASP.NET, really this really old technology with VB. And from there, I started to hear about this job called like data scientist, data analyst, data scientist, and I wanted to move in the direction because I really liked data, and so I started to transition into that role. But I discovered that I wasn't very good at it. Also, I didn't have the proper understanding of how things worked. And at the same time, I was just struggling. While I knew that writing SQL and doing kind of data engineering, I knew I was good at that. So when I left that role, I decided this is it. I'm sticking to data engineering. And I've been doing that for, I don't know, almost 20 years now. It's been a while and I still do it to this day. Like my title is like software engineer, but I do mostly data engineering. I do a little bit of Python. Interesting enough, for some of your listeners, I didn't do a single line of Python for the longest time, and yet I was able to move up in my career. So I have this kind of meme that says "Thank you SQL," and here's like my brand new car that I bought just by doing SQL, right? So learned Python, or rather, I'm doing Python now, but I'm not quite learning it. I'm because I'm using Copilot, so these code generation LLM tools. We can talk about that more. I know that you have a question about that. But so yeah, this is what I do, and I've always enjoyed kind of the technical side of data, like the data architecture, data modeling, data engineering, and but since I started writing my newsletter, I have delved a little bit more into the business side, and I've kind of learned some new frameworks, which I wish I had back when I was a data analyst. I know that that stuff would have helped me tremendously in that career. So now I'm sort of writing sort of in a retrospective way, both to help people that are in that space right now, but also as kind of like writing it to my younger self, if you will, right? Like, hey, here's some tools that could help you, become a much better business analyst, much better data analyst.
You also did something very similar for data engineers when you started exploring these recurrent patterns in SQL that led you to write your book. What was the motivation around that? Was it similar?
Yeah, it was definitely similar. So in one of the previous roles that I had, I happened to work somewhere in between data engineers were writing like shell scripts and Python and working with Hadoop and really low level stuff. And then the data analysts who were using SQL, basically writing queries on our big data warehouse to do their analysis. And I was the one who was checking their code because we were doing sort of commits to our repository of all the code changes. And looking at SQL that somebody else wrote is always an interesting perspective because I immediately started to notice things like repeated code, very long queries, 300 lines, 500 lines, 1,000 lines queries, a lot of repetitive stuff, or some of these queries would be very slow. And I could go and make one or two small tweaks and immediately have the query go from like taking 5 hours, 10 hours to only taking a few minutes or even a few seconds. And I sort of learned this stuff without really intending to, right? It just sort of I started to see it. And around 2020, late 2021, I've always wanted to write a book, right? That's always been my dream. And for the longest time, I couldn't figure out what the book was going to be about. But around late 2021, I was taking an online class that was about something that this guy Daniel Vassallo, he called it small bets. And the idea was that, hey, what is the smallest thing that you can do that you can sort of test a market or something that you can sell, for a minimum amount of money. And he had written a book called The Best Parts of AWS because he had worked at AWS at Amazon. And somehow the idea really got into the back of my head of like, oh, what if I did like the best parts of SQL? And I sort of looked into if you search for books on SQL, there are thousands upon thousands of books on SQL. But they all focus on the same things. They focus on either a specific dialect of SQL, like Postgres or MySQL or SQL Server, or they focus on here's how the syntax works, here's select, here's where clause, here's this and that. And I had sort of looking at SQL. I'd been looking at SQL from the perspective of a software engineer, and I realized that there could be these design patterns that are very common in software engineering. Things like single responsibility principle, or the Liskov principle, the open close principle, all these ideas that kind of make code easy to understand, easy to maintain, easy to debug, and sometimes even make the code more performant. And so these ideas kind of coalesced all into something where I'm like, oh, minimum viable SQL patterns. Like, okay, here's like the minimum set of patterns that you need to learn to sort of take SQL to the next level. Like once you know how to write a select query, which a lot of data analysts know how to do, now you want to make your queries in such a way that you can push them to production. And this is not just SQL that you're writing for a one-off report or just to like check something or to answer a question. This is SQL. Like this whole thing coincided with the release of a tool called DBT, data build tool, which took SQL from just a casual writing a query to actually working as a data transformation language. Now, SQL has always been a data transformation language, but what DBT did, it sort of created the ability to separate the steps of a data transformation workflow to distinct logical elements. So you can sort of clean up the original data here, handle nulls, renames, handle data type conversions from text to integer, from text to date, and so on. And then in the next step, you do something else, and then in the next step, you do something else. So you could sort of break down this very complex workflow into much more easy to understand and maintain steps. And my works happen to coincide with this because I was talking about how do you take this giant SQL query that does everything in one shot and break it down into steps that you can then put into flow. And then each of the steps are sort of independent from each other. So this idea of single responsibility, each step does its own thing. So that if something breaks, it's just like a car, just like an engine. You know that okay, it's only, let's say, the fuel, or it's only the oil filter that you need to do. So all these things become independent components that you can go in and change, fine tune, etc. And so some of the patterns that I wrote seem to kind of fit into this new paradigm of SQL. Up until then, SQL had only been used for doing reports, for writing queries, for just sort of ad hoc type of stuff. And even in store procedures, in something like SQL Server, people used to do store procedures, but even then, it was sort of like business logic, but it wasn't as easy to sort of separate into components and pieces. People still repeated stuff. This is where the book idea came from. I then, beginning of 2022, I wrote it in, it was just like in my head. Basically, it was just a question of how do I organize this knowledge into chapters. Took me about 2 or 3 months to write the book, and I think I published it in April of 22. Was when the book was sort of like released as an EPUB to the internet. I will say that before I wrote the book, I wrote a Twitter thread that captured the essence of the book. Like if you want to, I've been writing SQL for this many years. Here's like one way to think about it. Here's the different patterns. There's this. There's like performance patterns, modularity patterns, granularity patterns, and so on. And immediately that it went sort of viral in a way, right? And I overnight I added like 1,000 or 1,200 followers from my Twitter, and it was just it was a novel way of looking at SQL. Like there was only one other book that existed in that same vein. It was called SQL Anti Patterns, like what not to do. So yeah, this is how the book started. much. This was the background story.
As you were writing those, how do you feel like those patterns improve readability, but also at the same time impact performance of a SQL query?
Yes. So one of my core guiding, I guess, tenets or principles is that underneath that shiny new tech that you see, there's stuff that's been there. There's either technologies or principles or ideas that have existed for many, many years, many decades even. And I truly believe that these patterns, like the stuff that I wrote in the book, is stuff that will never go out of style, because as long as there are systems that need to be designed, these core ideas, these patterns repeat every time. Now, of course, the specifics are different, right? So you could take my patterns and apply them to something like Python, perhaps, although Python is a programming language, so it has its own thing. But if we're talking purely data transformation, you can take these patterns and apply them to a language like R, which isn't as popular these days. Well, maybe I've offended some R people out there. I'll say R is still pretty good, but Python seems to have sort of taken over as the data transformation language of choice. My point is that these patterns exist everywhere. So if you learn them, one thing that I noticed is that so I was working with SQL, and then I wanted to do some machine learning stuff. Given that I did not want to learn Python, I was actually against learning Python for whatever reason. I was just like, because I had that experience way back when I was still in college, I didn't want to learn Python. So I was using these visual machine learning tools. This tool called the KNIME, KNIME, which is kind of a visual tool for doing machine learning. And I learned that I could take the same transformations that I was doing in SQL, and I can do them in this tool with its components. So I could take sort of like the raw data, do the filtering, select the columns, do group by aggregates, et cetera. And I had the idea that, oh, so as long as I learn the specifics of the tool, I can take these patterns and apply them as is. Just like I can take the same ideas and apply them to a new domain, right? So for me, this triggered the idea that there's this knowledge that you learn that never goes out of style. So to get back to your question about performance, I do have performance patterns in my book that I write. Now, one interesting thing with SQL is that the performance is often tied to the database engine that you're working with. So if you're working with something like Postgres or SQL Server, these are transactional databases. So they're used for what's known as OLTP, so online transaction processing. And they're very fast if you're doing very few like very micro, very small transactions. You're saving or retrieving very few rows. And so if you work with a database like that, if that is your backend, you have to sort of tune your queries differently, as opposed to if you're working with a massive online analytical processing or OLAP database, such as BigQuery or Databricks or any one of these tools, where the you're processing gigabytes and gigabytes of data in seconds. So the specific patterns of performance are slightly different depending on the tool, but there are sort of generalizable principles that you can apply across databases. And this is what I wanted to write in my book, because I wanted to make it independent of any one database system and independent of like current or future database systems. And so I was able to extract things like, okay, if you don't need to process all the rows of a table, filter them as early as possible. Like if you create a CTE at the top of your query that says only give me yesterday's data, and then everything underneath that CTE or downstream of that CTE works with just that subset. So the entire query is therefore faster, as opposed to, let's say, you don't filter, you only filter at the very end. Now, some of these engines are pretty smart and they can see that you're filtering and sort of propagate that filter all the way up to the top. But if you don't know if your system is going to be able to do that, or like you can't sort of just trust that the system will do that all the time. So you as the engineer can go in and filter the data as early as possible. Another one is limit the number of columns. Don't just do a select star. If you have 100 or 200 columns in your table, it's going to try to select all of them in memory, and then you filter later on. It's a lot easier that if you only if it's a lot easier and faster that if you know that you only need 5 or 6 of those columns, select them as early as possible and then work with those columns downstream, right? And then things like unnecessary sorting was another one. So people always, like, I used to see this in production code where analysts would create a CTE and then put an order by in the CTE. Probably because they were testing the query and they said, okay, yeah, this query looks fine. I need to sort the results. So they copy paste that order by, they do a bunch of joins, they do a bunch of other things, and then they do another order by at the very end without realizing that they've just doubled the time that it would take to process. So I have a pattern that says don't sort in your query, sort in your, let's say, in your BI tool, right? You always sort the data when you present it and in the presentation layer. You don't want to sort it in the database because that's a very expensive operation, regardless of what engine. I mean, it could be a really, really fast engine. If you do sorting or if you do window functions, which automatically do sorting, you get poor performance. So yeah, so that's performance is definitely an important aspect of the patterns of book.
Hearing you talk about those performance patterns is bringing me up back to the time that I used to do data migrations. We had kind of a list, an implicit list that was being shared verbally between senior developers to junior developers on what are the things that you always need to do to make sure that your SQL is performant. And then there was kind of the hidden list that, because it didn't happen that often, it wasn't shared that often. And I remember now everyone talks about CTEs, but back 20 years ago, it wasn't that much of a thing. And I remember it was one of my go-tos if I needed to make something a bit more performant, is put it in the with statement. That was my sentence to my juniors. Just make a select in the with statement. That's something that I learned during my certification as an Oracle developer. And yeah, those were like those tools. Like you don't do a union if you can do a union all, because implicitly it will try to do a distinct and it's going to give you processing.
That's another one where I say avoid unnecessary distinct.
If you don't need to distinct, don't do it, because it will try to do it, and that's processing time. That kind of brings me to a follow up. In 2025, how important do you think it is for a data engineer to be able to read an explain plan? Because that was the tool that we used to use back in the day to understand where the problem was. Like, are you doing a nested join or are you doing a hash join? Like those kind of things.
So I work with Postgres, and I often have to deal with queries that just don't seem to want to complete. The query just keeps running and running and running, and I can usually smell it. There's this code smells. This idea of engineers who can sort of, this code doesn't quite look right, and there's a lot of like tacit knowledge that's baked into something like that. It comes from work experience. And so oftentimes I'll see a query that just seems to take too long. Okay, this query's been running for 15, 20 minutes. Do I expect something like this to take 15, 20 minutes? No, it shouldn't take that long. Okay, so what's going on? Let me write and explain. And to be quite honest, I don't fully understand all the specifics in an explain statement, but it is very important to at least understand, like, oh, this look at how many rows this query is expected to process, and it's doing an inner loop join, and it is sort of like it's like 300 million rows times 300 million rows. Okay, this thing is going to run till the end of the universe. 300 million times 300 million. And so a lot of those things you learn in computer science when you take like in algorithms and you learn the big O notation. And so a lot of this stuff, a lot of this knowledge has come back to me. And again, it's not just the like you mentioned specifically query plans, and I think that's important to understand to some degree. And there is a SQL book that explains how to read these explained statements. There's a few. There's one that I like. You can put it in the show notes because I don't have it off the top of my head. But in this day and age, you're kind of thinking, oh, who needs to worry about that? You know, we have these AI agents that are going to be able to do everything, right? Well, what if now you have some code that was written by an agent, say, and then it's not performant? Like you need to kind of understand what the heck did this agent do, and what is it actually, what's going on under the hood, right? Why is the database taking so long? Why is this query just taking so long? So that knowledge doesn't go away. That knowledge is still valid, still important. And you kind of, I mean, you can't just blindly program stuff. I mean, this whole vibe coding thing, where people that are non-software engineers are just writing code. And I look at it and shake my head because I think like, well, this code, who's going to maintain this code? Well, maybe AI can maintain. Like, yeah, but no, not really. Who's going to maintain it? Who's going to debug it? Who's going to make sure that it's performant? Who's going to make sure that it's safe and secure, that it's not accessing stuff that it shouldn't access? So that knowledge is and will continue to be, right. It's just like those COBOL developers these days who are still. I read somewhere that mainframes are still a big business, like $1 billion business. Mainframes are still being sold. People are still programming in COBOL. So this stuff doesn't go away just because new tech is there. And when, let's say, as we say here, when push comes to shove, you still have to be the one diving into the muck, as we might say, the code. Not be afraid to dive into the muck and understand what is going on under the surface. We're never getting away from that. That's what I'm trying to say.
So that's a perfect segue for the installment that I have prepared for after. We call it copy paste in this show, is where a guest gets the chance to push a question forward to another guest. And this was a question from Simon Potenza, which relates exactly to this. How do you see this statement of AI is going to replace software or data engineers? Like, what are your feelings around this? Do you believe it?
Yeah, so I actually wrote a little bit about this. There is kind of I guess you can call it a philosophical razor, or like basically a heuristic, a shortcut for understanding stuff like this. It's this Latin phrase called cui bono. Cui bono, which means who benefits. Whenever you see a statement like that, think about who benefits. Who is benefiting from AI replacing humans? Oh, it's the people building the AI. So if you ask yourself this question and if you see who is making these statements, it's usually someone who's heavily invested in one of these AI companies. For example, the CEO of one of these companies or a big investor in one of these companies. And why are they making this statement? Well, because one, they want to create attention to themselves, like it's sensationalization, I guess. It's one way to think about it. And two, they want their company to be the one that you think about when you're thinking, oh, like it generates a lot of FOMO, a lot of fear of missing out, right? And it's all designed as a way to get us to start to use this technology so that these companies make money and have huge valuations. Now, is there some truth to something like this? Nobody knows the future, right? Nobody can predict the future. But the way that I've been able to kind of understand this is that we haven't yet seen the negative side effects of something like this. Of if you go ahead and replace your workforce with like one person and a bunch of AI agents, what are the side effects? Is your code still going to be as good? Is it still going to be performant? Is it still going to be safe and secure? Is it still going to do the work that it was designed to do? Is it like a mission critical? Would you ever use AI to build like a let's say like a mission critical operating system for, let's say, an airplane, right? I read somewhere that there is a threshold of how many bugs you can have per lines of code for mission critical software versus like your everyday software, and it has to be like one bug per million lines or something ridiculous like that, right? You can't have that. You can't have some AI write that. There's no way. No matter how good things get. The other way that I like to think about this is, if stuff breaks, who's going to fix it? Is the AI going to be able to fix it? Okay, so you hire you employ these AI engineers, let's say, and now they're writing all this code. Well, is anybody checking it to make sure that it's doing the right thing? Is there tests that are being written that are supposed to, like, someone has to check? Even if you hire junior engineers, somebody has to check to make sure that the stuff that they're doing is correct. Well, who's going to be that person? It's going to be somebody who knows what they're doing. And the other thing is, like, isn't it interesting that these companies that are claiming that OAI is going to replace engineers are actually hiring engineers? So yeah, my take on all of this is like, yeah, let's wait and see. In the meantime, I'm still gonna learn the things that are important, because there's another side effect that I've been seeing, which is that people that use a lot of this stuff start not only to become lazy, but start to forget and not learn anything. There is this phrase that is I forget who says it on LinkedIn, but it's brain rust or intellectual atrophy. And I really like this term because it's like it's telling you that, okay, by you using this technology, you're not learning anything. You're not improving. You're like, in order to become an expert in any field, you have to have seen a lot of different scenarios and be able to then see, okay, yep, I noticed that pattern. I noticed that pattern. You wouldn't be able to learn this stuff if you're coding with AI. Well, you might say, well, the companies don't care. There's another thing that I will say here is that right now, this AI and these agents, their costs way outpace the money that they're making. So if you look at anyone, whether it's Anthropic or OpenAI or any one of these companies, yes, they're giving these models out for free, or they're charging, $200 a month or whatever, but they're being subsidized by investors. There's people pumping money into these companies in order to keep them running. Like, they're actually running in the negative, in the red, as we like to say here. And what will happen once, let's say, you as a company actually implement these agents and you fire your workforce or most of your workforce? Will the costs of these agents stay the same, stay what they are today? I don't think so. I think these companies are undercharging in order to take market share, just like Uber did take market share from taxis, just like Airbnb did to take market share from hotels. And look at where they are today. If you take an Uber today, or if you go to an Airbnb today, it's almost exactly the same as if you were to take a taxi, if not more expensive, or if you were to go to a hotel. So what's the lesson in here? The lesson is that prices you see today for this agents or AI or whatever are not the prices that are going to be there in 5 years. It may very well be that by the time that the prices catch up to, like, by the time these companies start to make profits, they're going to keep charging more and more for these agents. At some point, these agents, I guarantee you, will become more expensive than having actual employees. So anyway, that's a bit of a longish take on it, but these are the things that I wrote when I when I thought about it, I kind of realized that like yeah, the economics aren't going to be there always as they are, because what is the motivation behind companies replacing people with AI? The motivation is to save money. You're hiring these agents because they're cheaper than your employees. They won't be cheap forever. that's that's my but these companies don't yet understand the I think the smart ones do, and they're kind of like they're running their experiments on the side, and they're kind of seeing, okay, let's see what we can do with AI, but let's not go as far as like cutting into our workforce.
Microsoft with Power BI, same exact thing. For almost 10 years, they gave it for free. And then after a while, it became a paying model because it wasn't sustainable. And we see it with companies as well when they decide, most of the times, I'm not going to rent tool X, I'm going to create it in house because it's cheaper. And then in the long run, your OPEX is going to be like 2 or 3 times as if you were renting something that is an industry standard that everyone uses and you don't have to care about the price of maintaining it. Going back to SQL, I would like to get your advices on a couple of subjects. But first of all, there was a quote that I heard from you, but I know it's not your quote. I would like to hear your thoughts about how that relates with the job of a data engineer and how important do you think it is? I have my personal opinions on it as well, but the quote was accountants don't use erasers.
Accountants don't use erasers. Oh, I remember this one. What that quote means is that if you are doing data modeling, it is a very good idea to think of your data as immutable. And using that concept of immutability, you can create a model that represents reality, both as it is today, but also as it was at any one point in time in the past. We as data engineers like to truncate and reload or replace data because it makes things faster. But if this is a data model that represents the performance of the business in time, it is a very good idea to think of it in terms of like a ledger, like an accounting ledger, which like if you make a mistake with your money, with your bank, if they make a mistake, they don't erase it and put a new value, just like we say, oh, we made a mistake in this table, let's run an update statement and fix the mistake. They add another transaction that offset the mistake. So if they overcharged you, they add another line item that kind of undercharges you, and so in the total, everything looks fine. And I believe when I mentioned or when I said this quote, I was referring to a very specific modeling technique called the activity schema, if I recall correctly. And the activity schema is a way to model a lot of things in your business in a ledger. And this ledger is meant to be immutable in the sense that it's not like a dimensional model where you go and you replace stuff in the fact table, or you go and you update the dimensions. The nice thing about this is you can sort of store the data as you see it today. And if you want to, if something were to change, you just add another line, and then you create your query or your system in such a way that it can sort of compute the state of the world, as you might say, at any one point in time. So if you want to go say, what did the data used to look like a year ago? Your ledger is unchanged. You could just go back and say, okay, this at this point in time, we had this thing and this thing and that thing and that thing, and the dimension looked like this, and so on. And then you can handle the translations in code. I think that's what I was referring to when I was talking about the accountants don't use erasers. It's a very useful way of thinking, because if you look at any of these advanced modeling techniques, I believe maybe Data Vault. I haven't done Data Vault before, so those of you who know Data Vault, forgive me for making any sort of grave mistakes here. but I believe that the way that the historicals are tracked in a data vault are by keeping a record of every. Yeah, what I was trying to say is that there are certain modeling techniques that are built on immutability, the ability to sort of say that I'm going to keep my data as it was, but because things have changed now, I will handle that in my translation layer. One of these ways, so I haven't done any activity modeling myself, although I did write about it because I thought it was interesting back then. But I've seen another modeling technique which relies simply on just taking a daily snapshot of all the tables. And the beautiful thing about this is, again, this like an accountant. I mean, maybe accountants don't add lines where things don't change. They don't add redundant lines, but in this particular modeling technique, you keep a copy of the data every day, even if it is the same. And what this allows you to do is to go back and forth in time at any one point and kind of like be able to compute things much more easily. There are ways around it where you just, if you don't want to keep that much data, you can only store when things change. But this was the beauty of that technique. So it's just it's a way of thinking about data modeling in terms of immutability, which makes it when data changes, it causes all kinds of issues, especially when dimensions change, when you have to deal with drift, like the slowly changing dimension problem that you may have encountered. So yeah. Anyways, that's it's been a while since I thought about that quote, but yeah.
It's an interesting concept that it's easily applied to SQL to make sure that once you look back into historical data, you get a bit more performance, but also reliability about what is that. Because I've seen over the years, as you move along forward in time, it gets more complicated to go back in time and say, this was exactly how it used to look like in, I don't know, 2021 January 1st at midnight. Becomes a very expensive query to do, but if you have like immutability or snapshot, you just filter the data until that point and then you just calculate.
Yeah, and I had to do this in one of my early jobs where all of a sudden we started to get these questions of, hey, what did the data used to look like a year ago? So that we could compute the growth year over year a lot more easily. And we didn't have snapshots, but the developers who had written the code had done kind of a smart thing where they had stored a date. There was a date. This was the original date when this transaction was stored. And then there was another date when things changed, and another date when basically things are today. So it was once I discovered how they had done it, I thought it was pretty brilliant, but at the same time, it was super hidden. Like you had to like go through these mental gymnastics to figure out that, oh yeah, this is like the status of this reservation was booked at this point in time, but then it changed because they rebooked to another date, let's say.
And how do you make sure that you keep your SQL skills sharp? What resources do you use for that?
Well, I mean, I write SQL every day. That's my job. And to be honest, I've reached a point where I can do most of it sort of with my eyes closed, as they say, and I haven't really learned anything new. And this came to bear recently when I learned a new sort of thing, a new concept, which I hadn't seen before. And this worked in Postgres. I was quite surprised. And it was the filter statement. So the filter statement works inside of an aggregation function. So you could say count star filter where date prior to this in one statement. And once I saw it, I was like, what is this? So I started to look into it, and it turns out that the filter statement has been in the SQL standard for many years. It's implemented by most of these databases, including Postgres, which I work with. Not all of them have it. I don't know if SQL Server, for example, has it, but I know BigQuery and all these other tools have it. And it was a way to, you used to have to say, if you were doing these segments of aggregation, let's say case when, you would say count, and then inside count, you say case when date prior to this, otherwise this, and then you close your count statement and that just counts that particular segment. Well, with filter, you could just say count star filter where date prior to this, and you didn't have to use a case statement. It was a lot more cleaner. So SQL still surprises me that I'm like, wait, I didn't know that. That's pretty cool, right? So the way I sort of keep up to date is, I mean, I'm always on LinkedIn, kind of looking at new technologies. For example, DuckDB is something that I've been looking into for many years. They've written a lot of synthetic sugar for SQL. Like they've made a lot of things very, very easy. For example, pivoting data or unpivoting data. Extremely difficult if you don't have the right function in there. In fact, I had to do a pivot where I took, data that was very long, so like one ID but multiple categories. Like this particular entity belongs to these five categories, this other entity belongs to these four categories. And what I wanted to do is have one row per entity and then one column for each category, and then a yes, no, yes, no, yes, no. Right? That's a simple pivoting statement. And you can do that by using, max, case when, et cetera, et cetera. But I discovered that in a tool like DuckDB, you could just say, take this, max, pivot, boom, and they handled all the intricacies internally. And I wish I had something like that in Postgres. I developed it using DBT, which meant that I could use like a for loop in Jinja to like I could grab the columns. Sorry, I could grab the distinct values of the category ahead of time and then create, because it's different every time. Is for every case it was different, so I didn't know what the columns would be ahead of time. I couldn't just hard code them, so I had to create something with Jinja, with DBT, to grab all the columns, grab all the distinct values, loop through them, put a max around it and all of that. So the way that I stay up to date is facing problems that I'd never faced before and kind of looking online and seeing how did other tools solve this, maybe asking ChatGPT. Sometimes actually I've been amazed by the ChatGPT solution to a problem that I was it was a relatively simple thing, but ChatGPT managed to do something quite clever. I thought that it was able to do something much more elegant. Like for your own edification, if you are listening out there, what you can do is you can write something yourself and make sure that it works, and then take the same problem and run it through one of these LLMs, ChatGPT or Claude or Gemini, whichever one, and see what the answer looks like. And say, okay, yeah, that's what I wrote, and compare the two. And if you see something that you haven't seen before, you can go into the documentation and say, what is this thing? This is how I discovered the filter statement. Wait a minute. What is this filter statement? Wait, this works in Postgres? Let me try it. Oh, it works. What? What is the documentation? Oh, it's been here since Postgres 9.0. Wow. Okay, I learned something new. There you go.
That's really good advice. I'm kind of sad that I didn't have that when I was writing a lot of SQL, but I kind of remember a similar story when I discovered lead and lag.
Oh, lead and lag.
My world opened up just to know that if you are grouping something, you can now get a record before and a record after.
Yeah, basically what you could do, those rolling sums that you could do in Excel so easily. You had to do a self join, because I used to have this book of like snippets of code, SQL, and it said, hey, you want to do a rolling sum? You have to join the table with itself. But you have to join it in such a way that you only join a portion of the table from one point and before, or from one point. Basically doing the same thing that lead and lag do. For me, that was when I discovered CTEs, the with statement. Mind blowing. I was like, whoa, okay, wait, I could do this? This is because I used to do, subqueries up until that point.
And I think this is a great happy note for us to end the show. Thank you so much for coming. What is the best place for people to know more about you?
I'm quite active on LinkedIn these days. I used to be on Twitter as well, but I have abandoned Twitter. So you can find me on LinkedIn. From there, you can find some links to the book. The book is on Gumroad and on Amazon. But if you go to I also have a newsletter called SQLpatterns.com, SQL Patterns, PATTERNS.com. It's called data patterns. I haven't quite figured out the right. It started as data patterns, but then I owned the domain SQL patterns, so that you can go there and you can find all my writing there. There's also a link to the book on SQL patterns, so all my writing is there. I post on LinkedIn at Ergest X is my handle. So I use that handle pretty much everywhere these days. So on Twitter, on LinkedIn, on any of these social media. I don't post on Instagram though. That's so yeah. If you want to find out more, this is. I also have my old blog at ergestx.com. There's some SQL writing there, but I haven't written there in a while. I mostly write on Substack these days.
And any ideas for a second edition of Minimum Viable SQL?
I released sort of a second edition, more of an update, version 1.5, I called it, about a year and a half after the launch, where I replaced the database. I was using BigQuery for because I have I have a project in the book that people can work through to kind of learn the patterns. And I used to use BigQuery because they had a free data set, but some people could not access BigQuery. So I released an updated version that uses DuckDB, and it uses DuckDB and DBT. I added a section on how to apply the same patterns to DBT. I use a lot of that stuff. So I've been using a lot of my software engineering patterns to DBT, to my day-to-day work. If I were to do another edition, I would expand more on kind of this, like how to use these patterns with a tool like DBT. But for the time being, I'm focused more on metrics, KPIs, business performance, that type of stuff. So basically the applied side of data. So don't have any plans for doing an update on MV SQL. I'm thinking of doing something else though, like another book that's more related to metrics. But I know that metrics and KPIs and business intelligence is not everything in data. I know that there's a big chunk of data work that has nothing to do with metrics or KPIs or business, and it's more just like data processing and scraping and loading and all that. Yeah, if I did anything, it would have to be something like, ETL type of patterns. Thought about doing a data modeling course or book for a while, but I think Joe Reese is doing that. So I think that's already covered. So yeah, I mean, I don't have any plans. I'm trying to sort of like keep my technical knowledge where it is, and actually start to focus more of like how do you apply data to making better decisions in the business. So
That sounds like a future book is there in the makings.
we'll see. We'll see.
A big thank you to Ergest for spending time in his busy schedule and having this chat with us in the 4th of July. If you took any value out of this conversation, consider dropping us a like and subscribing to the show. And to anyone that is still listening, see you next time away from the keyboards.